Welcome back, class. So you know that rocks are made out of minerals. You know some of the basic mineral groups. Today we'll mention silicates again. So remember that silica and oxygen, and it's some of the most abundant elements on our Earth. So many rocks contain silicates. So there's all types of rocks, but there's three main rock families. We have igneous, metamorphic, and sedimentary. In the rock cycle, you get this beautiful tale of rocks being able to be anything when they grow up. So you have a rock and it can be anything in its future. Just like when you were told when you were a kid, you can be anything when you grow up, so can a rock. Except for a rock doesn't have to settle into a career path, it can become any other type of rock based off of what conditions it's exposed to. So looking at the rock cycle, I'm going to move my camera closer to my board here. I have in blue the words are three main rock groups. We have igneous, metamorphic, and sedimentary. Going clockwise, I have some long red arrows showing that the igneous can become sedimentary, sedimentary can become metamorphic, metamorphic can become igneous. Going the opposite direction, we have orange arrows. Those indicate that every single transformation that you see with the red arrows can happen in the reverse. So a metamorphic can become a sedimentary, and a sedimentary can become a metamorphic. The same goes each way for any of the rock groups. And now we have these self-repeating small circular black arrows. This shows that a metamorphic rock, which forms when subjected to heat and pressure, if it becomes subjected to even more heat or even more pressure, it can become another type of metamorphic rock. It'll be even more metamorphosed. Sedimentary rock is the same thing. This can form through precipitation of minerals, or it can form from individual grains forming a clast and lithifying together. If that rock then dissolves and reprecipitates, it'll be a new sedimentary rock, or if it becomes eroded and then relithifies, it can become a new sedimentary. Igneous rocks form from molten material. So if you have a rock that melts and then resolidifies, it's forming a new igneous rock. Igneous rocks can reform many times over, and every time they do that, they're living in this part of the rock cycle, melting, hardening, melting, hardening. So any part of the rock cycle can lead to another type of rock. So I will walk through an example of that. So recall silicates. Remember the silica tetrahedra that forms most of our minerals on our planet? It then makes sense that silicates will form most of our rocks. So here we have basalt or lava rock. So this is something that was once molten, solidified, thereby forming an igneous rock. So this rock, we'll learn in a future video what felsic and mafic mean, but when something is felsic, it's lighter in color. So here you have it's kind of reddish, pink. It's not the deep, rich black that you might see in other basalts. So this has a lot of silica in it. It might have a bit of potassium too, giving it a pink color. So this basalt, picture it maybe extruded on a volcano in Hawaii, and through hurricanes and wind and water and rocks tumbling down the hill slope of the volcano, little bits and pieces will break off, thereby forming sand. So you should know that sand is made up of other rocks, but little tiny fragments of that. You can see in my sandstone here the individual grains that were once part of other larger rocks. So you could imagine that this lava rock on the side of a volcano in Hawaii, as it's tumbling and breaking down, those grains get transported to the beach, and in the shallow subsurface, you have loose sand on top, but once it has a little bit of extra pressure, some water working on it to dissolve and then reprecipitate grains of minerals, you'll start to get the cohesion of individual grains, and through lithification, get a stone or a hard rock. So this, even though it's made up of sand, it's all cohesive, it's together. I can wipe the grains off if I'm really keen to, but this here is a sandstone. So this is a sedimentary rock that could easily have formed, I don't know what all the individual grains in here are, but could easily have formed from bits and pieces of igneous rock or metamorphic rock. So this one's still light in color, it's still made up of the same minerals as the original rock, but now they're in a slightly different form. Now let's say that sandy beach in Hawaii, that area gets more and more buried through sediments that are sloughing off as the island erodes, and materials get more and more buried and they're under more and more pressure. And so through that pressure and heat exposure, you can start to get some metamorphosis occurring. So this silica-rich, quartz-rich sandstone would metamorphose into quartzite. So recall that word quartz from our minerals group. If you add the suffix "ite," although we usually see that suffix "ite" in mineral groups, when you add "ite" to quartz and you get quartzite, it represents the metamorphic form that is rich in silicates, but this one here, it's almost like a giant crystal of quartz itself. So you get the metamorphic rock quartzite. So that is an example of the rock cycle just with these three hand specimens. So each of the different rock families has its own characteristics and it has different subtopics within each one, and we'll go into those. But your take-home message from the rock cycle is that any type of rock can become another type of rock.